Observations can be in different styles. It depends on how or what we're actually looking at. One, they're the kind of observation that is too detailed. When it becomes too detailed, you can look at this. This is trying to show so much detail, a kind of a splinter style. If you can see, there's so much breaks and breaks and breaks. This can actually lead to some loss of some geological discontinuities. Another style one could use is an ideal kind of style, which is not so much detail that that can actually preserve some structural, structural details, and also have some kind of balance with geology and some balance with your structures. That is the second kind of style, which is most ideal. Another kind of style of observation could be a kind of a lumper style. You can see, if you look at this, there is a lumper kind of style here. There's no detail. In this kind of style, one could lose some subtleties and can lose some structures in this kind of style. But at least one thing with this is that you've identified a bigger kind of rock unit here. I will show you another kind of this kind of observation style in one of the projects. Okay, let's look at this. When looking at this regionally, you can see that if you're observing this, there's a very clear demarcation here. This is a clear rock unit that is actually quite different from what we are looking at here. Actually, where we are looking at now is the Aeromagnetic linoleum, most within the lower Benny Trough. If you look at here, you can observe this as a different rock unit, and you can see a very clear boundaries, which also seem clearly, matches the geology, the regional geology. Let's remove this. You can see this is the boundaries. So this is actually showing the boundary here. You see, it's showing a boundary here, and that is it. So you can look at this distinctive feature here. That's what we're saying. When you are observing, try to first of all get a whole rock units that are very distinctive. Then you can now detail in. If you look at here, this is a different unit. This is a different unit. There's a different unit here. Now, this is actually where most of the mineralization within Ishiago Abakaliki Antiquarium is resting. Then, if you look at this is one of the underground mine. It's resting here. Then we have another underground mine here also. So if you detail in to this, you can see where we have most of the mines. These are existing mines. The existing mines, you can see they are within the inflection points, within the boundaries. You can see it here. Now, also you have to observe that the fabrics, the regional fabrics, are in the northeast. So that's why it is very, very important that you understand the geology where you're actually working, so that you might not be, so that you can make a very good interpretation. So if you look at this now, these are some of the existing mines, all found within the inflations and all that. Now, let's detail in. Let's detail in to some areas also where we'll have some interesting mine. This is another area we'll have one of the big mines. you can see. So actually you can see a very distinctive rock unit here. Though this is a 2VD TMI. So there are a kind of, the more you try to detail your interpretation, you filter out, the more your data gets a bit noisy. The 1D will also show you less noisy kind of data. So that is just it. Now let's look at this place also, where we have one of the good mines here. This is another mine located along this location. You can see that this is a very clear anomaly within the surroundings. Okay. So magnetic rock units actually, as we've seen, that is mappable, it's tangible, it's something that we can verify either by drilling or by mapping. See, the observer's objective in delineating magnetic rock units is to estimate the location of the shape of the top of the magnetic rock unit body causing a particular magnetic anomaly. So the analogy in geological mapping is tracing of an exposed contact. So the task is just to read through the magnetic field pattern and focus on the bodies that are actually causing them. So rather than simply record the magnetic field pattern themselves. So when recording these magnetic rock units, there are four things that are actually always on our mind. What we actually ask, is this body shallow or deep? So that means we need to use the right filter to know that we are dealing with the shallow features and not deeper features. Secondly, is this body narrow or broad magnetic body? If it is narrow, what must be giving this kind of narrow magnet? Is it a seal or a dike? Third one is we need to understand these magnetic anomalies that our expressions we are seeing, is this body single or group of related kind of units? So, and the fourth one we need to also understand is this body complex? So we can see, let's look at this. You can see a very linear, narrow magnetic rock unit. So this is how we can identify. You can see by main observation here, we can see a very linear, narrow magnetic rock unit running northeast. Here also running northeast, you can see, and also here we can see here, and this, and these are actually carefully, depending on the scale, we actually carefully identify all these linear magnetic rock units. You can see here, these two are actually parallel, running parallel. So they are very, very important in terms of exploration. Also here and also here. So this is a kind of a linear magnetic rock unit. This is a one vertical derivatives of RTP. Then let's look at another polygonal rock unit. You can see this is not actually linear. This is broad. This is actually broad. Also here, this is the grayscale intensity, and this is the colored scale. So you can see polygonal rock units as identified in this. Now, there are things we need to also note while delineating magnetic rock units. There are about 5 things we must note, and the first one is the sources of the magnetic rock unit. We must understand that whatever we identify as a rock unit that is given an expression on the surface, we can actually prove that by drilling or also by mapping. Then secondly is that whatever we are expressing on the surface or within the magnetic rock data, aeromagnetic data, that those units are actually, they can be modeled into shapes and they are also tangible. Then third one is the resolution issues, the issue of resolution and ambiguity. We must understand that whatever expression we are getting is a combination of various depth features that are giving us that. So there may be kind of interferences from the shallower features from the deeper features and all that. Then another one is we need to understand that we need to put this in separate layers. Separate layers. Why do we need to do that? Because when we are observing, there are going to be a kind of subjective methodology we are going to adapt in our second stage of interpretation or in our lines of work. As we work, we bring in more data and more data. So as more data that are coming in, we are subjecting our interpretation to reality. So that's why you need to make sure that the observation layer, the first ones, are in different layer from the second layer. Then another one is that we must read through the magnetic field pattern to trace the location and shape of every magnetic rock unit. Look at discontinuities and pattern trends. What is actually the discontinuities? When we're talking about discontinuities, we're talking about some of the breaks that we see in aeromagnetic data. These breaks could be faults, could be so many contact zones and all that. So these breaks actually go in different kind of pattern, as we can see here. So these observations are typically more subjective and often requires personal judgment. So however, they are just as important as the magnetic rock unit in documenting whatever the interpreter sees in aeromagnetic data, so as opposed to what they interpret geologically. So the degree of subjectivity dictates that these observations should be treated as subsidiary to the magnetic rock unit, and in some cases it is preferable to draw them on a separate kind of paper. So that is just it. So when we are talking about breaks, we are talking about maybe faults, refracture zone, the shear zones, the unconformable contacts zones and all that. So these are the common sources of geological discontinuities, and they are frequently expressed in aeromagnetic data. As a matter of fact, this after identifying the magnetic rock unit, whether it's linear or whether it is broad, then we try to identify these breaks. These breaks act as a conduit for mineralization. This is actually where we are heading to. When you've identified the faults and the fractures, the shear zones or the striation zones, this is where the accumulations are. This is where the hydrothermal deposit actually formed. So that's why we need to understand how discontinuities and patterns are actually trending in magnetic rock unit, how they actually appear in observation methodologies. Then, but when we are interpreting breaks, most of us, you find out that we draw so many lines, and sometimes we lose details by drawing so many lines and call that this is faults, lineament maps and all that. That by most of the time you see that the lineament maps that are actually in the field are not even fruitful, because of not paying attention to what we are drawing, not taking some precautionary measures in interpreting some breaks. So perceivably range of linear features may not be related actually to faults and contact as delineated. So we must understand that. Also, we need to understand that aeromagnetic data reflects magnetization variations that are occurring in different depth, both for shallower kind of features and for deeper kind of features. Then third one is that the trends that we normally observe can also be tenuous and magnetization that can also be found at magnetic zonation boundaries. So this actually needs to be noted. Also, because of the subjective nature of this class of observation, it is actually advisable that we pay much attention and exercise some kind of restraint or be very conservative in drawing our lines, because I've seen so many people draw every kind of line and call them fractures, features, linears and all that, and at the end of the day you found out that they confuse the main You get confused with which one is the actual thing from what we are looking for. So if you look at this, this is the first vertical derivative of TMI. You can look at this. This is a gray image. If you look at this, actually you can see a very fine feature here, telling you that this is actually a boundary, possibly this is a sedimentary terrain. There is a boundary within here. Then if you can see here, this is actually fine, showing this. You can see there's no data here. Then if you look at this, you can observe something here. You can see there's a clear boundary within here. You can see a very fine feature here, texture here. Then look at this place. You can observe you can see a kind of folds kind of pattern here. You can see very distortions, highly distorted area. You can see. Then there is a trend going here. Now, if you look at any of the lines that was actually drawn here, they were actually drawn with every sense, every sense that shows that yes, there is a feature we are trying to observe here. If you look at it, the more I zoom in, you can see that these are very clear, linear, narrow features. Now, we can still pay attention to details later on, but first of all, look at the lines. You can see that these lines are well represented to show, first of all, first stage observation. This is kind of first stage observation. Now, this observation is in different layer. When you bring in more subjective data, actually you can see what will mean. You can begin to interpret some of the boundaries. If you look at here, there is a kind of granitoid kind of texture around here, which has actually been verified with the geological map within this zone. So you can see also a fine texture within this zone, and you can see a kind of sharing along this zone. You can see kind of fold here and all that. So this is what we are talking about when you are observing. Now look at this place also. You can see a finer texture around here. So if you want to look at this regionally, there's a clear indication that there is movement. There's a movement along this and movement along this. So along this line and along this line. So you can see that most of the things trend northeast in this direction. So there is a clear boundary of highly deformational activity within here and here. So the whole of this area is distinctive, different from here, and actually different also from here. So if you look at this area, this is a different geology. This area is actually different area, and this is actually a different area. So this is actually a boundary. This location is actually a lower. It's a boundary between the sedimentary terrain and that of a complex basement complex terrain here. Thank you for actually listening. Ensure that you subscribe to our YouTube channel for future notifications, so that from time to time you will get some of our free videos, and there are some of our trainings that will give based on registration, and some will actually give based on request, and all that. You can also have access to that.